Hello, I hope you all are doing fine. This is your question number 2 on moments. The question that you see on the screen is from your AS past paper. So this is your entire question, not a big question it is. If you want, you can pause the screen, attempt the question yourself, come back and look at the working of it. So I believe that you are back on the video and ready to look at the solution of it. And please do not forget to subscribe to the video because your subscription means encouragement for me. And I get to get an idea that you're subscribing. It means that you are liking the videos. And please do stay in touch on the comment boxes. Post your queries. There we can have a discussion. I can clarify your questions, your doubts and your queries in the comment section. Alright, so here we have part A. Define the torque of a couple. So how do you define torque? It's just a 2-mark question. Distance between the forces multiplied by one of the forces. Why is it a 2-mark question? Let's look at the mark scheme. So why? Because you have to clearly specify one of the forces. Do not miss this term. Multiplied by perpendicular distance between the forces. Please do not at this level of AS forget to mention the term perpendicular distance. Perpendicular distance between what? Between the forces. So that's why it is a 2-mark question. Always refer the mark scheme and try to understand why a particular question is carrying that much of a mark, because you're getting judged or you'll be scored on 2 valid points. So if they are saying that a torque question is of 2 mark, most probably whenever this kind of a question will come in your examination paper, it will carry 2 mark, and that's how it will be scored. So that's why solving past paper questions are very, very important. It gives you an idea how the marking will be done by your Cambridge examiners. B part, a wheel is supported at a point P on its center of gravity as shown in this figure. The plane of the wheel is vertical. The wheel has a radius of 25 centimeters. The 2 parallel forces are 35 newtons and 35 newtons acting on the edge of the wheel in the vertical direction as shown in this figure. The friction between the wheel and the pin, and the wheel is negligible. List 2 other forces that act on the wheel. State the direction of these forces and where they act. So what could be possibly 2 other forces? That's always clearly easy to identify because they have not mentioned the weight. So there should be some weight acting downwards. If there is a weight and there is a point of contact, there has to be a reaction force as well. So what do you have to mention? You have to list the forces and you have to also mention their direction. So what do you mention? You mention weight. What is the direction? Downwards. What is the other force? Reaction force. What is the direction? Up or upwards. Alright, let us look at the mark scheme as well. Weight vertically down. Vertically is in the bracket, means it's optional. If you just say down, that also is correct. Normal force, or you say it normal force or a reaction force or a contact force, they are all synonym at point P. Upward, or you can also say vertically upward, doesn't make any difference. If you are saying vertically, you are more specific. That means your practice of writing the question is more neater and more valid, right? You're practicing well enough. Very good. So second part, calculate the torque of the couple acting on the wheel. So what is the formula for the torque that you mentioned here? Just apply it here. So how much is the torque? One of the forces 35 multiplied by the distance between them. How much is the distance? 2 times the radius. 2 times 0.25. Centimeters has to be converted to meters. Take care of it. Now solve it in your calculators. If you are quick at calculation, there should not be a problem. 7 5 so 35, 3 17, so 17.5 should be your answer. Let's see. Yes, 17.5. Alright, now the next part. The resultant force on the wheel is 0. Explain by reference to the 4 forces acting on the wheel. How is it possible that the resultant force is 0? 1 mark question. If you see, what do you have to say? The 35 newtons which is up is equal to the 35 newtons which is down. Right? They are equal and opposite. Similarly, the weight which is down is equal and opposite to the reaction force which is up. So everything is cancelling out each other, right? You can clearly explain it, easy. The two forces of 35 newtons are equal and opposite. The weight and the upward contact or the reaction force are also equal and opposite. Simple and an easy question to talk about. This was an easy question. State and explain whether the wheel is in equilibrium. We know that the resultant force is 0. For any item, any object, any body, any mass to be in equilibrium, there are 2 conditions that need to be fulfilled. What are the 2 conditions? Go through the theory video on the conditions of equilibrium. The link is attached in the description box to understand it properly. The 2 conditions of equilibrium. The resultant force should be equal to 0. The resultant moment should also be 0. Resultant force is 0, that we have understood in this part of the question. Resultant force is 0. But is the resultant moment also 0? In this particular situation, is the resultant moment also 0? Resultant moment 0 means moment is equal to total moment is 0. Moment 0 means turning is 0. What is the formula? What is the definition of moment? Turning effect. Moment 0 implies turning is also 0. Is the turning here 0 really? Look at the picture. This force here is creating a turning this way. This force, other 35 newtons, is creating a turning this way. So overall there is a turning happening. The wheel is turning in anti-clockwise direction all throughout. The turning is not 0. Moment is not 0. So resultant moment is not 0. That means it is not in equilibrium. So what do you say? That the resultant moment is not equal to 0. Why? Because you see turning is happening. Turning is happening. Right? That's how you write your answer. Resultant moment is not 0. Therefore, the wheel is not in equilibrium. You see with your own eyes that the wheel is turning anti-clockwise. The 2 forces are turning it anti-clockwise. So therefore, the wheel is not in equilibrium. So that's how you explain the working of it. Not in equilibrium, as the resultant torque is not 0. Torque means moment. So usually whenever you get the questions on moments in your exams, they are pretty easy and straightforward as compared to many other topics of AS physics. So if you do not want to make mistake on this topic, practice more and more questions on moments, because it is one of the easier topics in your syllabus. Alright, and second thing that I would like to highlight here is that please do check the description box for the related theory videos to understand the theory, so that you do not make mistakes in the exams. Alright, so this was the end of this question. Stay connected for more practice questions on this topic of moments. Thank you so much.